Hello watchers, my name is Moaz Corena, a software engineer, and in this series of videos I'm going to walk you through the process of getting Imagination Technologies' PowerVR SGX530 GPU IP to work with the latest stable kernel on the beaglebone black. This was a topic of a workshop I've given a couple of weeks ago, but I thought I should reproduce it for the interwebs. The stable kernel we're going to be working with is 4.7.6, although in this video I'll be talking about kernel 4.7.4 or 5. This is because it's been a moving target. In fact, as I'm creating this video, the kernel is already at 4.8, so we'll just stick to 4.7.6, but the procedure should be the same. In fact, I think kernel 4.8 introduces a fix that will save us the effort of applying a patch related to TI's EHR PWM device tree entry, but I'm not really sure. It was just some mailing list claim. So the series is a bit slow, as I find it very hard to talk while typing. Not much of a multitasker here. So this first video will be walking you through the whys, and it'll also brush on the hardware parts involved, as it's not a very typical setup. Then we're going to get into cloning the kernel, configuring it, and setting up our bootloader, our file system, and all that good stuff. We're also going to test our DRM setup, and all that will happen in the second video. And then goes the third, fourth, and fifth videos, and they will be the real payloads of the series, as the workshop was focused on dealing with kernel module shims from vendors and working with user-land blobs from GPU IP vendors. So we'll be focusing on that. We'll also use Imagination Technologies' real-time performance gauging tools to verify that our GPU is doing what it's supposed to be doing. If you know your way around embedded Linux, you probably want to jump ahead to those videos. And okay, let's jump in. Starting off, what we're going to be working with is, of course, the beaglebone black, and we are gonna need a power supply for that because of the fact that we're using an LCD module, 7-inch resistive touchscreen, that requires its own power, so you can't just hook the USB thing and have the beaglebone black power the LCD module. It's necessary. And the 7-inch resistive touchscreen is that's actually what I've found. That LCDW50i whatever is what I found on the very obscure datasheet of this LCD module. I got it a few years back from a Chinese company that just sells this stuff, and I don't actually have the proper datasheet that goes through the display timing and all that stuff. And for me to get there, I had to look at source code that was provided by that same Chinese company, and basically just port the whole thing to the device tree entry for this LCD panel. We're going to go through this in detail in maybe this video or the next. I'm only concerned in this series with porting the SGX530 PowerVR GPU drivers, because those the focus of the whole workshop was on porting stuff that are not open source, stuff that you just can't really look at the datasheet and see all the registers and the details of the hardware and figure out how to actually fit that thing in your own kernel. You're basically blind from both sides. The first side is the hardware details, so you have absolutely no idea what you're dealing with. It's just a chip that you can't even see. And on the other side is the vendor-provided blobs that generally work on this is the thing with GPUs and embedded systems, that those blobs are generally user space binaries and libraries. They don't generally get included in the kernel. And what happens is that the vendor provides an open source adapter in the form of a module that is installed in the kernel, and that adapter, that module, does all the translation between the user space blob and the kernel facilities that interface with the hardware. Enough talking about that. We're going to get to it in detail in about a video or two. So the next thing, you need an FTDI USB to serial adapter. I grabbed one off of some local company. I'm based in Kuala Lumpur for now. And that is, of course, because you need to speak to your device over UART. And then the other stuff that I'll figure out, because I had this idea that I could just expand this series and basically work on porting more blobs into the kernel. I'm not very familiar with the beaglebone black. In fact, I have no idea what that cape manager thing does. Generally, I work with a vanilla kernel with very little tools from the vendors. It's the nature of my job, because I freelance a lot, and today I might be working with a Samsung-based system on chip, and tomorrow a TI-based, just like this project here. And it would be it proves very hard to keep track of every vendor-specific tools and configurations. So, well, I work with the kernel as it is and try to use as little as possible from vendor-provided stuff. Okay, so this is one thing that I'm using in this project. It's not really a requirement, but it serves as my cape. See, where's my mouse? There's my mouse. This FFC connector is internally, like within the board, connected to this port here. And this port is large enough for me to deal with it with through-pin connectors or wires. Okay, and the reason why I'm doing this is because of the fact that I do not have a cape with an FFC connector to actually hook the LCD module, the 7-inch LCD module that I have, to my beaglebone. And for that, I actually need wires. All I have is the beaglebone module itself. That is all I have, and of course the power supply. So this board I got this a couple of years ago, also from the same Chinese company that provides this stuff, and it might look complicated, but it really isn't. It's it may be, but we're not really using any of this stuff. All we're using this is as an adapter. I want this. I want the LCD module to hook to this guy, and basically just give me direct pinouts, so I can hook it to the headers, the female headers on the beaglebone black. I'm going to show you a live or a video of this thing while we're working with it, and you'll see a lot of jumpers left and right, but just know that this is not really required. This is something that I did because I'm cheap, and I did not want to go out there and get it. Actually, I did order a cape that came with an LCD FFC connector, but I got it off of eBay for, I don't know, some amount, $14 or so. And the problem with, or no, it wasn't 14. I don't remember, but it wasn't really a fit, because the LCD module that I had is different from the LCD module that cape is built for, and I didn't pay attention to that. It was just a not very rational purchase. So I have that cape. It's sitting somewhere in some drawer, and it's not being used. So we're going to use this instead. The host tools that are required, I wouldn't say required, but it's just the setup that I'm going to work with is a Linux machine. Bear in mind that the actual workshop that I'm reproducing here was not a hands-on workshop, so that the attendees did not have their own modules, and they basically sat there while I did everything. So a Linux machine, I work with Arch Linux, Arch or Arc. I'm inclined to call it Arc because I think it comes from architecture, but I'm not sure. So Arch Linux or whatever. Anyways, most of this stuff are not covered in this series. So your TFTP server, your NFS server, your RPC bind service, those things are going to be different, are bound to be different for each development machine. And so if I go into explaining how to set that up on Arch Linux, you probably aren't going to be, that's not going to be useful for most people watching this thing. So just know that you need to set up your TFTP server, your NFS server. Okay, there, just make sure that you have NFS version 3 supported, because version 4 is not yet, the client for the NFS root functionality in the Linux kernel is not yet fit for use. It cannot load the root file system over NFS version 4. So just pay attention to that. Your RPC bind is very, 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 very important, even though you may think that it's not. Moving on, the text editor. The text editor that I will be using is Vim. You can use, of course, whatever works for you. I will occasionally branch out and use some tools to basically get me through certain stuff, like comparing two files and stuff, and using a visually acceptable diff output. But most of this stuff, most of what we're going to do, or what you're going to be watching me doing, is going to be done within Vim. Of course, you need Git. We're going to clone many stuff, and make patch and curses for the menu config thing. And finally, you need a terminal emulator. I'm using Minicom. I've recently changed actually from Kermit to Minicom because I just couldn't justify the complexity of Kermit. And that's about it for the host tools. We may need some other stuff, but you can figure it out. I'm gonna be doing everything step by step. So if you don't have something that I'm using, just get it and understand how it works. Okay, so let's get to the pros and cons of actually doing this. I'm not sure I actually defined what we're trying to do here. In a nutshell, what we're trying to do is we're trying to detach our product from the vendor provided Linux kernel. So generally, whoever your hardware vendor is, the company that makes your system on chip or your development board, will provide you with a kernel that works with their SoC. Now, generally speaking, and this is from my experience, I've seen that those kernels are usually compiled with a lot of bloat. A lot of SoC types are incorporated into the same kernel to support, a wide variety of their products. Those kernels are generally older than what one would want to work with starting a new product. Well, I think this is not very true. This isn't true for TI, as they're pretty close. I think the latest kernel for their AM335X SoC, which is the chip used in the beaglebone black, is 4.4, if I'm not mistaken, 4.4 point something. So that's not very far, given the fact that today we stand at stable mainline stable kernel 4.7.4. So yeah, that's pretty good, in fact. However, this is just an example. I may not, if I had that decision, I may not have deviated from TI's provided kernel. but I may have because of the other stuff. Now, the latest mainline kernel patches are generally ignored by those vendor-provided kernels, and I don't know, it depends on your product. Maybe you want those patches in, you want those fixes, those specifically the ones that are concerned with security. You may actually want that in your product. Not may, you probably do, but well, it really depends. And finally, you have full control over the source code, and that's something I think every software company has to value very much. Now, the cons of this is that there's no vendor support mostly. This isn't really an absolute thing. They would generally provide some support, but I don't know. I've been through the forums, and I do that a lot. Like, go about all the support forums for every vendor that I work for every device that I actually work on. Just have a general feel of the attitude of the support team or support service. And with TI, there's a mixture of things. I'm not sure if this is because of the fact that they have limited personnel there. They can't really just open their support indefinitely, and but they provide some pretty good support when it comes to their own software, their own provided kernel and modules and everything. But I've seen in a couple of instances where a support person replied saying that we do not provide support for such and such software. Specifically, was it Debian or one of those distributions that work on the beaglebone Black. Now, another con that you have is the fact that you'll have very high initial cost. Of course, that depends on the experience of your team, but this is generally a thing that for you to move from whatever vendor-provided kernel to a kernel that is cloned directly from mainline, you'd have to do a lot of work specifically for blobs, which is what we're going to address in this series. And then the potential for suboptimal implementation, basically that you could, and we are going to go through that in this series, since our focus is specifically on getting the PowerVR GPU to work, because you don't want a GPU sitting there doing nothing while your CPU takes all the responsibility that shouldn't be his or hers. Now, we are going to ignore some side effects. Maybe the PRU subsystem won't work because we're just not going to pay attention to it. We're going to have some initialization problems. The message, the kernel log will complain about stuff that we will just disregard. Of course, if you're going for a full product development, these are things you're going to have to work on and fix. And this brings us to point 2 of the cons, which is the initial cost in time. Okay, so let's discuss what's covered in this series. We're going to cover configuring the kernel. The stable kernel, as of today, is 4.7.4, so we're going to clone that and go through the configuration. We're going to build the root file system. Well, we're going to use build root for that, just because it's not really necessary, but it makes life easier, and it's a good way to go. Again, it's not really necessary. You could get your own busy box and configure it, and get your own libraries and cross-compiler tools and set up everything yourself. But I strongly advise against it. It's not productive. And we're going to cover working with 7-inch LCD display. As you may know, the beaglebone Black is configured by default to work. Actually, the AM335X SoC itself only fixes this, only supports 24-bit LCD displays or panels through an errata. We're going to work through that and see how the device tree would map to the hardware connections that we have for the LCD display. As again, the LCD display that I have is actually is a pretty standard 24-bit LCD display, and there's nothing really too specific or special about it. And even if you don't have it, you probably could just map whatever I'm doing to whatever LCD module you have, or maybe you're just following this for the procedure that we're taking to actually port the SGX driver. Maybe you're using HDMI or something. I just found it easier to reuse the equipments that I have, but the process will probably be the same. And we're going to be using DRM because frame buffer is history. Not quite, actually. If you look at the kernel used by the latest Android device or Android version, that is Android N or 7, it uses, I think it's called Angler, or was that for the previous thing? I don't know, but I don't think it makes use of the direct rendering management subsystem in the kernel. I think they're still stuck with the frame buffer stuff, as their kernel version is what, 2 years old or something. It's 3.10, and that is your state of the art Android implementation. That's the latest. Anyways, that's another issue that we don't care about for now. Then we're going to work with porting SGX530 PowerVR driver, like we talked, like I said, and then we're going to work with compiling PowerVR example. I think that's wrong. Anyways, we're gonna download Imagination Technologies SDK and compile their examples and then test them. And the way we're going to test them is by downloading PowerVR's Tune, I guess, or I think they're called Tune, or whatever. It's basically a process that runs in your embedded system and hooks to it's a server that runs in your embedded system and you can hook to it remotely over the network, of course, with a desktop monitoring program that will tell you the CPU load, what is happening, what's the GPU load, basically diagnostic information that we can use to confirm that our implementation actually works and that it actually takes the load off of the CPU and gets the GPU to do what it's supposed to do, and some other stuff that we will be deciding. Now we're going to be working with building the kernel, and that will happen in the next clip. See you there.